You swapped the SIMs, you used a different proxy on each one, you kept them on separate devices, and Telegram still tied your accounts together and took them down. That is the part that makes people give up. They assume Telegram cracked something clever. It did not. Telegram fingerprints accounts in layers, and if you do not know what those layers are, you keep changing the wrong thing. This video shows you exactly what gets checked and how an operator keeps legitimate accounts alive. Telegram crossed 950 million monthly active users in late 2024, and it has been hardening abuse detection ever since. The pressure comes from two places. Regulators in the EU are demanding platform accountability under the Digital Services Act, and there is the plain operational reality that fraud and coordinated inauthentic behavior at scale ruins the product for everyone. So the detection system in 2026 is far more sophisticated than it was in 2021, when a fresh number and a VPN were often enough to disappear. This is for the operator running real accounts who wants them to last. Here is the plan. First, what Telegram actually fingerprints, from the protocol handshake down to your contact graph. Then the 4 cheap fixes everyone tries that do not work and why. And finally, the handful of controls that genuinely move the needle, plus the failure modes that quietly kill accounts even when your setup looks right. Start with where fingerprinting begins, which is the protocol level. The mtproto specification is public, and what it shows is that every session initialization carries a bundle of client metadata: the app version string, the device model, the OS version, and a session identifier derived from the Android ID. This gets logged on every single connection. None of it is hidden or exotic. The signal comes from inconsistency. When those fields contradict each other or contradict the IP you are connecting from, that mismatch feeds straight into the risk model. So a fingerprint is not one number. It is a set of fields that are supposed to agree. The layer that actually gets most accounts banned is IP to number reputation. Telegram correlates each session's IP against the registered number's country, the carrier SN behind it, and a historical reputation database built from prior abuse. A Singtel Singapore IP connecting to a well-aged +65 Singapore number is a clean pairing. The country matches, the carrier is real, nothing fights. A data center /24 block connecting to 50 different numbers across 50 countries, all registered in the past week, is a textbook abuse pattern. No single factor pulls the trigger. It is the combination of signals crossing a threshold together. Then there is contact graph analysis, which rounds out the picture. Telegram watches how your social graph develops, how contacts get added, whether that is phone book sync or username search, whether contacts interact back, whether the density of the graph matches genuine human use. This is the one that catches operators who get everything else right. The device is real, the IP is clean, the warm-up looked normal, but the graph shows the accounts all friending each other within minutes of being created, with no replies and no reciprocal activity. That shape reads as inauthentic no matter how good the IP looks. Now the fixes that do not work, because skipping these saves you real money. The first one everyone reaches for is a residential VPN. The logic seems fine. If IP reputation is the problem, switch to a better looking IP. The flaw is that residential proxy pools rotate. Every rotation is a session jump. The IP changes, but the device fingerprint and the session identifier stay the same, and a stable device bouncing across a dozen IPs in a week is itself a signal. Worse, those pools are shared. The IP you get today might have been used by someone who got banned last month, and you inherit their reputation with no way to know. The second one is anti-detect browsers, especially for operators already running them on other platforms. Telegram Web is not the native app. It does not establish the same mtproto session, it does not carry the same device fingerprint, and it does not build session history the same way. The browser fingerprint spoofing that works for e-commerce setups does not map onto Telegram's session model at all. You are dressing up the wrong surface. The thing being fingerprinted is somewhere else entirely. The third mistake is data center mobile proxy pools. This is a real product category, and for Telegram it is mostly fraudulent. Vendors buy S10 blocks, paint them with carrier-looking metadata, and sell them as mobile apps. What Telegram actually sees is latency profiles that do not match a real mobile link, reverse DNS that does not match the claimed carrier, and IP ranges that already show up in threat intelligence feeds for past abuse. Telegram has processed enough genuine Singtel, Vodafone, Airtel, and MTN traffic to know what a real mobile network looks like. A fake mobile pool fails several independent checks at once. The fourth one is SIM shuffling. swapping numbers between accounts, or rotating numbers across a pool, hoping the change resets the fingerprint. It does not. The device hash, the session authorization key, the IP history, and the contact graph all stay on Telegram's side. The number is one input to the risk model, not the whole model. Change it while keeping everything else constant and you have gained nothing. You have just spent money on numbers. So here is what genuinely moves the needle. The single highest leverage control is keeping one IP from a real carrier SN permanently assigned to one session, not a pool, not rotation, one IP. When Telegram's risk model sees the same Singtel Singapore IP connecting to the same session every day for 6 months, that pattern accumulates reputation credit. The IP builds its own score independent of the number score, and disrupting that continuity even briefly for maintenance resets some of the trust you built. Stability is not just about avoiding a ban today, it is about banking history that makes tomorrow harder to flag. Second, a real device fingerprint, not an emulated one. The device model string, the build fingerprint, and the Android ID that Telegram receives in the handshake need to be internally consistent and characteristic of an actual phone. Emulators produce fingerprints that either fail those consistency checks or match known emulator signatures Telegram has already cataloged. Rooted or heavily modified builds produce fingerprints that fight the reported device model. Running on genuine physical hardware with an unmodified Android build solves all of this with zero spoofing. The fingerprint is real because the device is real. Third, contact graph hygiene from day one. How you populate that contact list in the first 30 days matters more to long-term health than almost anything else. Add contacts from the phone book through organic discovery. Let conversations develop at a human pace. If you are running a channel or a group, grow it incrementally. An account that jumps from 0 contacts to 1,000 in a week with no replies and no reciprocal engagement reads as inauthentic regardless of how clean the IP is, and once a graph anomaly flag is set, it does not clear on its own. Fourth, login cadence and session continuity. Never log in from 2 locations at once. Telegram supports multi-device sessions, but the IP pattern still matters. If your session runs from a Singapore IP and you separately log in from a London endpoint just to check messages, that concurrent session from a distant IP is a behavioral anomaly. For a managed account, the right move is to keep the session in one place and reach it remotely through a screen forwarding interface. Rather than opening a second Telegram login, the same authorization key running uninterrupted for months is itself a positive signal. There is one more input worth understanding, which is number, age, and registration context. A number that has been active on Telegram for 6 months or more with no ban history, originally registered from an IP that matches its country, carries real reputation credit before you do anything with it. A freshly issued virtual number registered from a data center IP starts at 0 or below 0 if that IP has prior abuse on it. If you are starting with a seasoned number from a real carrier, protect it. If you are starting fresh, budget 2 to 3 months of conservative behavior before doing anything high velocity. Number age is often a first pass filter that runs before behavior analysis even kicks in. Here is what a setup that actually holds up looks like. The session runs on a physical Android phone in Singapore on a real Singtel SIM with a static IP. The device has not been factory reset since Telegram was installed. The IP has been continuously assigned for at least 60 days before the account does anything significant. The owner completed the one-time verification once from their own device, then handed the session to the farm. After that, all access from anywhere goes through a browser-based screen forwarding session that forwards input to the physical phone. No new Telegram login is ever created. The authorization key never changes. Before you trust any IP in front of an account, run a basic reputation check. Look at 3 things: the carrier, ASIN, and country, which should describe a real mobile network and not a data center provider like Hetzner, DigitalOcean, or OVHE. A spam house block list results because if the IP is listed, you do not use it. And reachability to Telegram Singapore data center on port 443 because if that is blocked, you are behind the network level filter and that is a different problem with a different fix. If the ASIN comes back as a data center, or the IP is listed, the answer is the same. Do not put a Telegram account you care about behind it. Even with the right setup, things break, and these are the failure modes we actually see on the farm. SIM expiry and carrier recycling is the first. If a SIM goes dormant, the carrier can reassign the number, and then Telegram's verification codes start delivering to the new owner. A single voice call or SMS every 30 days on any SIM you're not actively using is enough to prevent recycling on most Singapore carriers. Carrier IP churn is the second. Some plans reassign IPs on billing cycles, and a single reassignment after months of stability creates a flag. If the new IP has prior negative reputation, you can get a soft restriction, degraded delivery, or removal from search with no explicit ban notice at all. Contact graph collapse is the third, and it is sneaky. If a large share of your contacts get banned in an enforcement sweep, Telegram sees your graph suddenly shrink, and an account that dropped from 400 contacts to 40 looks very different from one with stable organic growth. There is an account recovery flag too. If Telegram flagged you for review in the past and you passed a recovery challenge to get back in, the account carries a permanent elevated scrutiny marker. Recovery does not clear it. And finally, two-factor authentications. An account without it is easier to hijack and signals a weaker security posture to the risk model. Turn it on for every account you care about. So if you have been losing legitimate accounts to detection patterns you cannot see, the technical layer is solvable and most of the work is just consistency. That is what Telegram Vault is built to handle. We host the session on a real Samsung phone in Singapore, on a real Singtel M1 Star Hub, or Vivify SIM with one dedicated mobile IP assigned to your account and held stable. You bring your own number, complete the verification once, and the session lives on real hardware with a real carrier IP from that point on. The fingerprint is genuine because the device and the network are genuine. The behavioral side, the contact hygiene and the pacing, stays in your hands, but the infrastructure underneath stops fighting you. There is a concierge pilot, so we map your setup correctly before you scale. Use code TGYT for 30% off your first month, and the link is in the description at telegramvault.org. If this saved you from chasing the wrong fix, subscribe because the next video covers how to run Telegram without a SIM card permanently using the same hosted phone setup. Different use case, same infrastructure, and the same rules about keeping a session healthy. Thanks for watching, and I will see you in the next one.